So let's create some simple solid components using a sample as a starting point. Currently, Solid's main website is on GitHub. And at the bottom here, they have a link to their examples. And I would recommend, perusing these to get ideas. They cover a lot of bases, and there's, a real world demo that's, not trivial, and some other, demos like that. But we're going to use their simplest sample as a starting point. So this link opens a small project and code sandbox. That's an online IDE, that'll let us write solid components and experiment and immediately see the results. You make this a little bit bigger. So this project is written in TypeScript, but I'm going to change it to JavaScript. So a TSX file is a TypeScript file that contains JSX. So I'm just simply renaming it, and then I'll remove the very small amount of TypeScript. Takes it a second. There we go. All right, and you can see now the app is functioning as it was before. So this is a great sample. You can look at it yourself, but let's delete most of it and we'll build it up from a minimum state. So this is a very simple app with two source files, right? We have the HTML file that has a single div tag where the solid component will be rendered as a child of that. And the source file simply imports Solid's render function, then defines a component app, which simply creates a paragraph with hello as a child. And then it calls the render function to render the app component under the app div tag. So let's focus on state. That's an important concept with Solid. So Solid provides the create state function for creating the state. And the first argument is the initial state, which is in this case is just an object with a count value set to 0. Create state returns an array with two values, the first being the object you reference to read values from the state, and the second is the set state function that you use to modify the state. And these two pieces enable Solid to be reactive to changes. And this array destructuring syntax assigns the returned array element to two variables called state and set state. So let's see how we use these variables. So first we'll just log the state object after it's created just to see what it looks like. And to clean up the console here, we'll refresh. And you'll see in the simplified console that state is just an object, a simple object. Now, if you examine this in the debugger, the browser debugger, you'd see that it's wrapped in a proxy object so that Solid can intercept reads from the state, which is important for it to be able to do that. So here's some throwaway code that we can see how the set state function is used to update the state. All right, so the set state function has many overloads. It's very powerful. So here's just a few examples. The first set state example shows an overload that takes an object where any members that exist in this object replace the ones in the state. So in this case, we're just overriding the count with a value of 55. And any number of members values can be specified in this object. The second example is where the member name is passed as a string. And the third example takes the member name as a string, but instead of specifying a new value, it takes a function that is passed the current value and returns a new value. You can see in the console that it initially logs 0. The 0 is the initial value. Then this set state call sets it to 55, then to 25, and then this one subtracts 10 from that, so you get 15. So set state can take many more arguments if you need to walk down a deep structure. There are overloads that can update one element in a list. See Solid's documentation for a more thorough description of set state. So to make the state management more formal, let's put it in its own module. So I'll delete all this stuff. And I'll create a file called store.js that will manage, so it will be the module that manages the state for us. So this is a simple module that exports a function that creates the state internally and returns an object that provides read and write access to the state. The returned object contains a reference to the state object for read access and contains functions that perform specific updates to the state. We won't use all the update functions defined, they're just examples. I like this pattern of providing, canned updates functions instead of having components use the set state functions directly. And so the returned store object can be passed to any component that needs to read or update the state object. This is just one way of doing it. Defining a class that gets newed to create an instance that manages state works great also. You'll see that later. And notice that this module defines an internal create default value function and calls it when initializing the state, and also when in the reset update function that sets it to the initial value. And I found that at first I just set a variable that references this object, but create state uses that object and wraps it internally, and that object would be modified. So when I passed that same variable referencing that object to the reset, it didn't work. So I had to change it to a function that returns kind of a fresh copy of the initial state. So that's just something that's good to know. So let's set the state aside for a moment, and we'll enhance our simple component to accept properties so the parent can specify the text to display. Yeah, we don't need this anymore. All right, so with JSX, the props argument is an object containing all the properties passed to the component. So see how the message property is passed to the app component in the function that is passed to the render function. So the message value ends up being a member of props when the app function is invoked to render the app component. So you can see here it's passing a property of message, and then when the component's rendered, it just references the props.message to get access to that value. And you can see that now the component is using the value passed kind of from the parent. In this case, it's the render function. So let's change the app component to log the props object that gets passed to it, and we'll pass another property. So I'll refresh this to get a clean console. And so the app component is now passed a color property along with the message property. And in the app component, the color property is used in the paragraph's element style. And remember, the double curly braces are required to specify an object literal in JSX, and the style attribute can be specified as a string or an object. And you see that it works. And the logs propped object contains the two properties passed to the app component. These are passed as hard-coded strings, so the output is static. There's no reactivity. So let's change the component to use our store object. So we first import our create store function from our store module, and we invoke that to obtain our little state management object that we call store. Then a timer is incremented. The timer is started to increment the count value in the state every second. And the app component is changed to reference the color and count values from the past state property. You see the colors style comes from props.state.color, and the text comes from props.state.count. And you can see now that the app component is simply passed the state object that comes out of the store. And so you can see that the app is working again. It's incrementing the counter every second, but the color isn't changing because the state doesn't contain a member named color. So this is setting the color to undefined, which is being ignored. So let's add the color to our store, and we'll just say, oops, I want it to be a purple. All right, it's hard to see the text color, but it is purple. So let's change to set it a background color instead. So since this property is going to have a kind of a minus sign in it, which isn't valid JavaScript unless you put it in quotes, and so that's easier to see the color. All right, so let's do something strange. Let's make the color change depending on the counter being odd or even. So here's one way to do it. When we call increment count, so we'll change increment count so that besides just changing the count, it will change the color based on the count being odd or even. All right. And so you can see that it's working, but there are a couple of issues with this approach. When I refresh it, you'll see the text is initially shown as purple, and that's because this increment count and the color picking logic isn't run until the increment count is invoked after 1 second. And there are other methods that set the count, so we'd have to add this call there, and wherever it's updated, kind of remember to set the color. So there's a better way to do this. Solid has the create computed function. First I'll change this back to, get rid of this call. All right. And we'll go to our store, and after we create the state object, then we need to import create computed from Solid. And you can see as soon as I added that create computed, the colors start working, even though the increment count doesn't change the color at all. So it's initially set to purple, and this create computed is passed a function which simply sets the color state based on whether count is odd or even. And if I refresh it, you'll see that the initial color is not purple. This takes effect immediately. and Solid will automatically rerun this function whenever the count changes. So, do you wonder, I wondered how this worked when I first saw it. And of course, that's the reactive part of Solid. But how does this know, just simply by saying that, basically it's just saying set the state based on this. Well, how does it know when to call it? Well, create computed uses the same reactivity mechanism that makes the app component change its paragraphed child text whenever count changes. Right? It's the same mechanism. So let's dive into that a little bit. So let's go back to, remember, Babel, where we can kind of see the traditional way that JSX is compiled. So see how the default JSX compiler passes JavaScript expressions, the name and get, and the call to get name function. It passes them, as is, as get name and name. And so the expressions would be evaluated once when the component is rendered. Solid's JSX compiler does something different. It wraps those expressions in a function, allowing Solid to detect what state members those expressions are dependent on, and allowing Solid to execute them again when any dependent state changes. So let's see how JSX is compiled by Solid using the browser debugging tools. So we'll go back to Code Sandbox, and we'll search for the compiled code. But since app, appears many times in this large web site, we'll change this to XYZ app to make it more unique. All right, so then I'll open the debugger tools. And go to the sources, Control-Shift-F, and XYZ app. Search for that, and let's see. So the browser has access to our original code, but it also has the compiled code. So the big difference from the standard JSX compilation that we just saw is the props.state.count. See up here, we're just referencing this as the style that is wrapped in a function that returns that value, and props.state.color is also, wrapped in a function. So let's focus on this first call that inserts a text node as a child under the paragraph element. So the first argument passed is the paragraph DOM node, and the second is a function that returns the value to insert. So before calling the pass function, Solid's insert function goes into a mode where it records all accesses to state. Then it calls the function, recording each read access to any state value. The return value of this function call is used as the text node's value. And in this case, it would record that the child text node is dependent on the single count value. So calling the pass function not only determines a value to use, but also any state values that it's dependent on. Internally, Solid knows that this particular text node that it just inserted into the DOM is dependent on the state's count value. And it also keeps a reference to the pass function, so it can call it again to obtain a new text value when count changes. So I'll say that again. A change to count doesn't require the component to be re-rendered. Instead, Solid will invoke this function again, and the text node is changed with a new value. So that's the fine-grained reactivity. Very slick. But this expression, or any expression, JavaScript expression, can be, complex. So it can, it can be, many calls to other functions and everything. So what happens if the logic reads different state values depending on other state values. Meaning that, if this is a call, so let's give an example. For example, let's say there's an is count valid Boolean state value that when false causes the text to be rendered as the string invalid, but when true, the count state value is read and used. So something like this. So you see that it's going to check the state value is count valid. If that's true, it will then read the count value out of the state and use that. Otherwise, it uses a string constant invalid. So let's say that is count valid starts out as false. So the first time the component is rendered, the only state value read would be is count valid, right? If this is false, it doesn't read this value and it just returns invalid. And that's correct, because if is count valid remains false, but count is changed, it doesn't need to call this function again. Nothing will change, and so it'll remain as invalid. But then if is count valid is changed to true, right? It initially determined that this was dependent on that, so it would reinvoke the function that would return this expression. And this time it would record that both, since is count valid is true, it would then read count as well. And so this text node would then become dependent on both of those values, which is correct, right? If either of them changes, Solid would call the function again to see, what's the new value. And, change the text again and possibly record different dependencies. So, and the paragraph style is handled by a call to Solid's create effect function that is similar to create computed, which you saw that we just used to set the color. But when the control is rendered, create effect will call the pass function, tracking dependent state values that are read. Solid will reinvoke the function when any of those dependencies change. And so you see, go see Solid's API documentation page for more information on the create effect. So in this case, whenever props.state.color changes, Solid will call this function again, which will set the paragraph style, its background color, to be the value from the state. So you don't necessarily need to know how it works internally, but it helped me gain confidence that it will work no matter what I throw at it. The use of create computed to set the color state value illustrates a useful technique. But if the background color of the paragraph element is an internal design decision of the component, it really shouldn't be exposed in the state. So let's make the color decision simpler and internal to the component. So we'll first remove the color member from the state. And we don't need this. Okay. And in our component function, let's create a function that decides what the color should be and invokes that in the style object. So let's see. So putting color in the state allowed us to explore different Solid capabilities, but I like this better because picking the color is very simple and kind of a local decision that the component makes. So if any content, style, or attribute of the component is calculated by JavaScript code, Solid will detect dependencies on state members, and fine-grained updates mean that targeted changes are made when the state changes, instead of re-rendering large sections of the UI. So we'll put a log statement in the XYZ app function to see that the component is only rendered once. So let's refresh to clean up the, you can see that it's only logging that one time. So it's only logging, it's only rendering the XYZ app one time, and then all the changes are being done to the style and the child text reactively and in a fine-grained way. So now let's look at a common scenario where you want to show a list of something. So we'll change the state to store a list of numbers and add a couple of methods to add and remove items from the list. So to our state, we'll add a simple array, and then so we've added a function to add a value to the end of the list, and a function that removes the value, the last value from the list. And of course you could have functions that remove any item, from the list, but I want to keep this example simple. So let's modify our component to show that list. So first we need to import two new functions from Solid, show and for. Right. And then define a simple component that will display a value from the list. So put that here. Just call it value. And we'll change the XYZ app component to show the list after the paragraph containing the count. So get rid of this. All right. Seems like the indentations got messed up. That confused me for a second. Right. All right, there we go. So the show component is used to optionally show content. The when property specifies an expression that is evaluated to determine if show's child content will be rendered or not. In this case, it will show the unordered list of values if the length of the values array in the state is greater than 0. So if the when expression evaluates to false, the fallback property is rendered. In this case, a paragraph containing the text no values. And Solid's for component is used to render a list of something. The each property specifies the collection to iterate over. The child of the for component is a function that is passed an element from the collection and returns the element to render in the list. In this case, the function here returns an li element. I think that's list item for the child of the unordered list, with the value, this little simple value component as a child. And this value component is really, let's see, where is it right here, is really too simple to make a separate component, but I do this here to illustrate the possibility of referencing potentially complex components in a list. Right, this could be a big block of data that you want to put on the page in a list. So this illustrates that ability. And you can see that it's working, but the list is always empty. So to simulate user interaction or backend updates, every second after incrementing the count, we'll randomly add or remove an item from the list. So we'll change our timer. So after incrementing the count, 50% of the time, or if the values list is empty, we will add the current count value to the list of values. Otherwise, we'll remove the last value from the list. And this is a silly example, but it illustrates the concept of a list dynamically changing. And you can see the list is now rendering as it changes randomly. Sometimes deleting values, sometimes adding count. So initially I wondered how Solid renders a list as they change. So let's add a log statement to the value component to see when it gets called. And we'll refresh this to clean up the console. And so very interesting. The component function for value is only called when an item is added to the list, which of course has to be done, but it's good to see that it doesn't re-render the whole list. So the Solid's for function is managing the list of rendered DOM elements, removing and adding them in an efficient way. Yeah, this would be tedious to code manually. So that's it for this little project. I hope that filled in your understanding of how Solid works and how easy it is to create an app with custom components. In a later video, I'll create another Solid application outside of Code Sandbox in a Node project using Visual Studio Code.